Good morning, everyone. Welcome to July's session of the Talent Intelligence Innovation Accelerator hosted by Findem, an AI platform for talent decisions. Today's session is entitled AI and Employment Fairness, and over the next hour, we're going to cover two things that belong together but often get handled in separate silos: how AI can be designed to reduce bias in talent decisions, and what compliance and adverse impact scrutiny actually look like when that AI is deployed at scale. Our session today will be recorded, and we'll go ahead and get started. For those of you I haven't met yet, my name is Tina Shah Paikeday, and I serve as Senior Advisor for Responsible AI at Findem. Part of my work includes running education on the topic. And for anyone newer to our Talent Innovation Accelerator program, here's where we sit in the year. We're in the third quarter, which is about the AI governance quarter. We started in January with the future of AI in work and moved through the AI and decision-making quarter in Q2. And today we're focused on the fairness aspect of governance in July. And in August, we'll be looking at data privacy, followed by AI transparency in September. So you'll see the full faculty roster on the right here. And in just a moment, I'm going to introduce you to Jeff Pohl, who's joining us for the first time today. And his work at Warden AI is directly on point for the compliance section of this session. If you attended May's session on external data translation and search, a lot of what we'll cover today builds on that foundation, and specifically the work on how domain-specific AI models have behaved differently from general-purpose LLMs. We're going to go deeper on what the difference means for fairness and also legal exposure. And so with that, I am thrilled to be joined today by Jeff Pohl. He is the co-founder and CEO of Warden AI, and Jeff has extensive experience in AI and regulation technology. Before founding Warden AI, he led product at digital identity unicorn on Fido, as well as Chip Financial, Signal AI, and Quench AI. Jeff holds an engineering degree from Oxford University in machine learning. Welcome, Jeff. We're so glad that you're here today.
Thanks, Tina. Glad to be here.
Could you please share with us a little bit about Warden AI and the work that you do?
Sure. So Warden is a specialist AI auditing solution for AI systems used in employment decisions, and particularly in recruitment and talent acquisition. So we have a lot of insight on the specialist topic, and looking forward to getting into some of those insights on AI bias and fairness in the session.
Terrific. I'm looking forward to our conversation. And let me also just share where our arc is for the hour. We have three movements. And first, I'll be talking about responsible AI by design. I'll take us through the research on cognitive bias, how the architecture of AI tools determines its fairness outcomes, and what empirically changes when you move from general purpose LLMs to domain-specific models in a hiring context. We'll also talk about the dangers that domain-specific models can face. This is my section. We'll spend about 20 minutes or less, and that will be followed by compliance at the intersection of employment and AI that Jeff will be presenting, and he'll take us through what Warden AI's audit data shows about where AI bias is actually appearing in talent acquisition today. This is the section where we get into the 4/5 rule, position level audit methodology, and the questions you should be asking your own vendors. And then finally, we'll have time for questions and answers. We've seeded a few discussion questions about the current regulatory environment, and I'll want to make sure that we also have time for real-time questions from the audience. So with that, I will jump into the next section. Let's start with AI design. And before we can talk about compliance, we need to understand the mechanism where human bias enters into AI systems and what it actually looks like to design AI responsibly. And with that, I'll start with human bias. So for those of you who know a little bit about my research on bias in recruiting decisions, it's centered on Kahneman's famous dual process theory. System one in this model is fast and automatic. It's pattern-based. It basically feels like expertise, but in hiring, it's mostly bias firing, whereas system two is slow, deliberate, and criteria-based. It's also rare because it's cognitively expensive to use. And here's the problem that I wrote about in my article in California Management Review last year. We've basically built an entire industry around tools that accelerate System 1 bias. Search firms, ATS platforms, LinkedIn, they all make it faster to find someone who looks like the last successful hire. None of them fix the underlying cognitive problem that exists. And those are the biases that here appear on the bottom part of the slide. The first one is representativeness bias, where candidates are judged by similarity to some mental prototype that we have about the successful hire who we made last. Whereas availability bias is about more memorable people or recently seen candidates that we systematically overweight when we make decisions. And then finally, in terms of anchoring, initial impressions around company name, school, or title that are insufficiently adjusted when the evidence contradicts them is another bias that we have in our cognitive decision-making as humans. So one thing I'd like to ask you to do if you're following along in the chat is to enter one word or phrase. What's the bias you're most worried about in your own organization's hiring process? So as you drop those in, I'll just say one last thing about this particular concept. And what I want to argue is this, which I think the research does back up, is that AI, when it's properly designed, can do the system two thinking at scale, not because AI is smarter than humans, but because it doesn't get tired, it doesn't have a preferred archetype, and it evaluates criteria in parallel rather than sequentially. The question is whether the tool is designed to do that, or is it designed to replicate the patterns of past training data, which means actually replicating the biases. And that's an important distinction as we talk about different tools available. So I see that anchoring bias is one of the biases that we're familiar with in recruiting decisions. And let's keep that in mind in terms of human bias as we move towards AI bias. So before I share some initial evidence on how AI can be less biased than humans, I want to give you a framework for thinking about where bias enters AI. Suresh and Gutag actually published a taxonomy in 2021, which I find incredibly helpful. It's a framework for understanding sources of harm through the machine learning lifecycle. And so there are 7 distinct entry points that they talk about, and each requires a different intervention to remove bias from AI. I'll just say that the first 4 types of AI bias are probably most relevant to hiring, and they are historical bias, representation bias, measurement bias, and deployment bias. So let me go through those 4. Historical bias enters from the world itself. This is training data that encodes structural inequality before the model is even built. You can't fix that with debiasing the parameter after the fact. You need to actually design it in the right way. Representation bias enters at the data collection phase. If the training population underrepresents certain groups, the model underperforms for them. Measurement bias enters at feature construction, so resume proxies for job performance are imprecise and often group inconsistent. And then finally, and I'm highlighting this one in particular because we'll be talking about it soon hereafter, which is deployment bias. It's the one that's most often underlooked, but we have to keep in mind that tools used differently than their intended use produce unintended outcomes. And even a well-designed model can produce discriminatory results if it's deployed in a context it wasn't designed for. So I've highlighted it because we see so much of it despite having come as long and far as we have in terms of AI adoption. So many people have moved from AI literacy to AI fluency, yet how many times have we seen an AI novice or even a board director on the Nom and Gov committee use a large language model to quickly identify candidates? That is deployment bias probably at its worst, or some platforms have built in some guardrails for consumers who try to use their tools in unintended ways. Others with big names haven't done that yet. And I just tried this again yesterday to see if anything had changed over the last couple of weeks. So next, let's see what happens when you use LLMs versus domain-specific models to make recruiting and hiring decisions. So this is the slide that I wish every vendor conversation started with. because we use AI is actually not a very meaningful statement for compliance or fairness purposes. And the architecture of the tool, whether it's general purpose or domain specific, determines to a large extent whether the outcome might be fair. On the left, when we think about LLMs like ChatGPT, Claude, Gemini, these are pattern matching engines that are designed to draw inferences from training data. They are actually designed that way. In a hiring context, that means they encode historical hiring biases by default. Anzenberg and colleagues published a preprint study last year, which was called Evaluating the Promise and Pitfalls of LLMs in Hiring Decisions. They used roughly 10,000 real candidate job pairs to test the best general purpose LLMs out there, which ended up showing demographic bias for racial and ethnic minorities, as well as intersectional groups, even when gender parity appeared to hold. So the score variance was actually very large in this data set, suggesting that there were systematic disparities, not just random noise. On the right-hand side, on the other hand, a domain-specific model trained on structured, job-specific attributes with fairness constraints built into the model design actually performs differently. The data was from Eightfold, and the same study found that domain-specific models outperform LLMs tested on quality while maintaining equity across race, gender, and intersectional groups. And I want to highlight that difference, and the framing I want to leave you with is this, that accuracy and fairness do not have to be traded off for each other. The trade-off is false when the model architecture is actually right. But this still leaves us with the question of how does domain-specific AI compare to humans on bias? So I'm going to answer that question in just a moment. But before I do, I'm going to actually share with you a demo. And that demo is going to show you what brings together the best of both worlds. So this is a demo of Findem Studio. And we blend the beauty of natural language processing found in LLMs with a structured data set and competency-based attributes found in domain-specific AI. So again, we're bringing together the best of both worlds. And for those of you who are participating in our certification program, feel free to follow along in your own instance of Findem Studio or the MCP plugin for major LLMs. For those of you who don't have access yet, you can also access the service using the QR code on a token basis. And this is a video that we launched at Josh Berson's Irresistible Conference. So I hope you'll enjoy getting a feel for what the future looks like. And I'll ask you to do two things as you watch this demo video. I want you to watch what talent gets surfaced, what data gets surfaced. And basically with MCP, you're getting a general purpose model responding to a prompt that's sitting on top of a structured data set and defined attributes. And so let's go ahead and play this demo. Terrific. So hopefully that gave you a flavor of when you combine the natural language processing of an LLM, but it's sitting on top of a structured data set with attributes, you're kind of getting the best of both worlds. So let's return to that question that I asked earlier. Can AI actually be less biased than humans? And we had the opportunity here at Findem in last year's Innovation Accelerator program where we tested domain-specific AI against humans, and we found that domain-specific AI actually beats humans. So let me summarize what changed in the testing that we did across quality, diversity, and speed. Because the conventional framing treats these things as competing priorities, I actually argue that they're not. We can actually get better on all three of these things with AI. So first, in terms of quality, candidates with nonlinear careers actually meet the roles criteria now begin to surface. The prestigious profiles that don't meet the criteria no longer crowd out the slate, and that criteria are applied consistently across every single candidate, not just subject to evaluator fatigue or shifting standards. So next, on diversity, the underrepresentation in slates is largely a filtering artifact. This is produced by the same proxy logic that degrades quality. But when domain-specific AI is used correctly, higher representation follows structurally. And then lastly, on speed, I think this is the easiest one, but let's think about what's happening here. When the sourcing compresses from weeks to actually minutes, candidate pools are continuously evaluating the live market rather than just at a single point in time. And we have numerous examples of how millions of dollars and thousands of recruiter hours have been saved as a result of using AI. And we can actually do that and also deliver higher quality and diversity at the same time, removing the false trade-offs that we once thought we had to sacrifice one for the other. So just quickly, I'm going to summarize what's happening behind the scenes when we move from resume to attribute-based search. And the next slide makes the mechanism concrete. So traditional search is sequential. You read the resume, you form a first impression, the impression anchors everything else that follows. Whereas attribute-based AI evaluates hundreds of structured criteria in parallel. There's no first impression to anchor on. Traditional search patterns match to past hires and credentials, whereas attribute-based AI has no reference to past hires unless you explicitly build that in. In addition to that, traditional search relies on proxies such as company prestige, titles, and school names, whereas attribute-based AI evaluates what the role actually requires. So this representation finding, I think, is underappreciated. When you stop filtering on proxies, representation improves as a structural output, not as a program input. You don't need a diversity initiative if you've designed the search correctly. Diverse slates actually emerge because the filtering artifacts that were excluding people are now gone. And so that's what I love about the beauty of AI. When it's designed in the right way, can achieve all of these outcomes. Now, I want to be careful not to oversell AI because, as I've talked about a lot in the past, AI doesn't replace human judgment in hiring. It restructures where human judgment is most valuable. There are three things that AI genuinely cannot do yet, and I'll emphasize the yet, but let's talk about them: context, intuition, and discernment. First, in terms of context, the nuances and subtleties of a situation actually give it meaning. A model doesn't know that the organization just went through a leadership transition, or that the team dynamic has a specific gap, or that the candidate who looks perfect on paper burned bridges at their last role. Humans hold that kind of context. Second is intuition. Fast, automatic, system one cognition that I talked about earlier, which is grounded in lived experiences, cannot be encoded. This is the same system one that can produce bias, but it also produces pattern recognition that is sometimes genuinely valuable. The challenge is learning when to distinguish between the two, and only humans know that. Finally, discernment, understanding what trade-offs to make, figuring out when a decision is not a win-win. These are the hardest calls, and they belong to humans. So the flowchart at the bottom shows what this looks like in practice, where AI handles the sourcing and potentially the initial assessment, depending on the level of the role, and humans own final selection and retention or first-year success. The recruiter's role begins to shift upstream from expert intermediary to system architect. And that's actually a more interesting job. Recruiters are designing the system that makes fair decisions at scale rather than manually executing every step. So now that I've made the case for why good AI design can reduce bias, there's a harder question, which actually is going to speak to Jeff's work directly, is what happens when you run the audit and it says that you're fine, you don't have any bias. There's a recent study that came out that helps us to unpack this a little bit more before I hand it off to Jeff. So many of you have seen this recent study by Stanford, in which an AI assessment provider passed the audit, but created an algorithmic monoculture. So this is the scenario that this landmark study by Balmasani and colleagues at Stanford Center for Human-Centered AI just published in their paper called Algorithmic Monocultures in Hiring. The data set is extraordinary. 4.2 million job applications, 3 million applicants, 156 employers, all running through a single AI hiring vendor. This is not a simulation. This is real hiring at scale. And I want you to hold that framing. This is one vendor, 156 employers, because it's the setup for what the data actually reveals. So here's what the data showed. 3 things. First, 26% of Black applicants applied to at least one position where the AI system's outcomes triggered federal adverse impact scrutiny under the EEOC 4/5 rule. That's more than 1 in 4 Black applicants touched by a potential compliance violation somewhere in their job search. But the finding that I want you to internalize is this one, the one that should change how you evaluate every vendor audit you've ever received. It's the 10.62% figure. 10.62% of individual job positions showed adverse impact on Black applicants when analyzed position by position, rather than across positions. And finally, the third number, the 156 employers, one vendor, is where the concept of algorithmic monoculture comes in. When a single vendor's model is making decisions across an entire sector, that vendor's biases don't just affect one company, they produce correlated rejections at scale. So the critical methodological insight is at the bottom of the slide, is the one maybe you should write down. Aggregating data scores across roles makes position level potential for bias. A clean portfolio level audit is not the same as a clean position level audit. And I'm thrilled to be passing along to Jeff the next part of this conversation, so he can actually talk us through what rigorous auditing looks like and requires of us. Over to you, Jeff.
Thanks, Tina. Great segue and really insightful presentation. So I'm going to talk today about some insights from a report that we previously did on the state of AI bias. So as I mentioned at the intro, Warden AI, we specialize in AI auditing for bias in a lot of different systems in TA vendors and also employers and staffing firms that use those systems. So as a leader in that space, we have a kind of interesting position that we have a lot of data, aggregate data on how the systems perform for bias on average across the board. So I'm going to dig into some of the insights from that and in some ways surprising kind of takeaways that we've seen from it. Set the scene first, just a bit of an overview of some of the key AI regulations at play at the moment that focus on AI used in kind of employment HRTA type systems. There's 3 at the moment that are kind of live and in effect and particularly relevant, which are the New York City Local Law 144, California FIA, and this year Illinois HB 3773. And then we have Colorado passed and coming next year, and we have the EU Act as well, passed, recently delayed for many of the requirements, coming next year, but still very important. I won't dig into each one by one, but they tend to focus on the risk of algorithmic discrimination as a core part of what they're looking at. That may involve requiring third-party bias audits. It may imply regular ongoing bias testing, and it will typically have focus on transparency to candidates as well, among other details. So that's a bit of a high-level kind of themes of these regulations, and I guess the takeaway is that, and there's many more coming down the line with other states following suit, is that anything that is an employment decision or assisting an employment decision where AI is used tends to be the focus of these regulations. Not saying that you can't do that, just saying that if you're doing that, there's additional measures and obviously risk mitigation you need to consider because AI is playing such a key role in the process. Jumping into some of the insights that we found. So we all know, or we've probably all heard that AI can be biased. There's lots of headlines on that. Going back a long time from the famous Amazon case in 2016 up until the study that Tina just shared and others. And we kind of benchmarked some of the numbers here of the different academic studies that have been conducted into AI bias, particularly in kind of our space in TA and HR, and find that there's been an increasing amount of research that mostly finds that there's bias or can be bias in AI systems. So, we know that it is an issue. It has been confirmed. There are various studies that do that. But what those studies tend to do is focus on certain scenarios or certain types of AI system, and maybe more, maybe not as sophisticated, maybe not purpose built for talent acquisition, maybe a general purpose large language model like ChatGPT, and then maybe constructs a way that they can find bias. But that isn't typically the way that a purpose built, sensibly designed vendor would take to actually building an AI system. Common examples are AI systems in these studies are found to be biased based for sex and sometimes race based on their names. But most sensibly built AI systems wouldn't include a candidate's name in the AI. Like the AI would never see that attribute. So just on that one particular example, even if the underlying model would be biased, that can be in some cases fixed by just removing that from the AI system. So that's the kind of backdrop, right? We know there's studies and a risk of AI bias. And so we kind of gone and benchmarked that. And so here's a bit of the methodology behind the benchmarking before I share what we found in the numbers. It gets a bit technical, so hopefully don't glaze over too much, but we essentially use two different techniques that look and quantify the potential level of bias in a particular AI system. Again, these are typically recruitment or employment-based decision systems. One of those techniques is disparate impact analysis, which is not, a new technique. It's not just for AI. It's, of course, as many of you will know, used to analyze the potential bias and fairness of any selection procedure, looking at the aggregate, looking for significant disparities in the overall outcomes between groups like sex and male and female. And the famous 4/5 rule Tina was mentioning about, of course, looking at that as a threshold. So we can apply the same thing to AI systems, and that's one of the things that we do. And the other thing that we do is called counterfactual consistency. And that is a more kind of AI-focused technique that actually tests how the AI thinks in many ways. It tests on a kind of individual basis almost whether attributes that might be used to infer someone's demographic information, like a name, to continue that example, whether that actually has an adverse impact or not on the output. So we would construct scenarios where maybe, let's say it's a resume-based system. The resume is the same in the scenarios, except for these demographic markers like names and hobbies and interests, educational institutions, etc., have been varied to correlate with different groups and see if that affects the AI or whether it's consistent between those. And something you can't really easily do at scale with human-based processes, so you can't really analyze those that way. But with AI systems, you can of course run high volumes of statistical tests, and that's a very kind of powerful technique. And there's an interesting discussion point at the end about the EOC kind of updated ruling and disparate impact theory that we can maybe dig into on that later. So those are the way we benchmarked how we evaluate bias. And then so we went and did across a large number of audits that we do. We do a lot of audits regularly. We also pulled out information that we could find online that it wasn't even from our audits. And we found that on average across the board that 85% of AI systems that we had data on for audits were above that 4/5 rule threshold for fairness. So there was 15% of systems were in some cases below that, not necessarily in every case, but at least for some groups were below that number. But 85% were above for all of the tested demographic groups, which is not the worst performance in the world, and is an interesting finding in its own right. And then we find an even more kind of positive, I suppose, outlook when we looked at that counterfactual consistency, in which we typically look for a 97.5% consistency. So that means, in that example of the male versus female, resume or wherever the AI is, where everything's the same except for the demographic information, how much is it consistent? And looking for only modest changes rather than significant ones. We found that 95% of systems were above that threshold. So still potential bias, still real risk, but in the case of purposeful, AI systems dedicated to recruitment and hiring, it was a more positive story, I think, than a lot of the headlines and the studies would reveal. But not perfect by any means. And then we took it a step further and said, well, that's a benchmark on AI bias and how that compares kind of generally. How about we compare that to human bias, right? So even if AI bias is a thing and not perfect, how does it actually compare to the status quo of using human-only powered systems like we've been doing for the majority until recently? So to do that, we conducted a meta-analysis in which we compiled other academic studies or actual academic studies into traditional human-powered systems and evaluating bias, particularly around sex or gender and race, ethnicity. I should say, actually, all of this data is focused on those two protected groups, not on other protected groups in terms of this analysis that I'm speaking about today. And so, we basically pulled metrics from these various studies that have assessed, for example, callback rates between different people of different racial backgrounds applying for the same role with the same qualifications, this type of thing. And we analysed that and how it compared to the AI-powered systems that we have data on. And we found a quite substantial difference based on the data that we have. We found that the human-powered systems had an average impact ratio of 0.67, whereas AI-powered systems has an average impact ratio of 0.94. And to recap, impact ratio is the actual measure, actual metric within disparate impact, where one is all groups being at one is we've gone ahead too far. Is the theoretical ideal, so everyone would just be 1, 1, 1, and 1, and so the more away from one, the more biased the system is apparently behaving, and so quite a big difference between the average human powered system from those academic studies, from the AI powered systems that we had data on. There are, of course, caveats and if buts and things you could look into the data, but directionally, at least, it's an interesting finding. And then we can dig one layer deeper and actually look at how that compares across some of the groups in particular. So when we looked at then male and female under sex as a protected characteristic, we found that there was again quite a stark difference between the AI systems, which was quite positive. And so the AI system was a 0.98 kind of worst on average impact ratio, whereas in the case of the human-powered systems from the studies, it was an average of 0.71, which works out as 39% fairer for AI if you just take it at face value, which is a significant difference and potential improvement across that group. And then when we dig into the race and ethnicity data that we have for both of those, we found a similar picture, in some cases slightly even more disparity between how the kind of human-based systems behaved versus the AI-based ones, with a kind of up to 45% compared relative difference between the worst performing groups, which is obviously quite a big difference. So really interesting findings. I always think of the analogy. It's a bit of a different analogy in some ways, but the analogy between autonomous vehicles, where obviously the stakes are very high there with autonomous vehicles not causing injuries and harm on the road, but how we have this paradox in how we hold AI systems to such a high standard. Like we're very worried about how automated systems behave, and rightly so. But there's even one accident or one issue with the car from an autonomous vehicle. People react really kind of strongly to that versus human drivers causing accidents all the time, every day, at a very high scale. I feel like with AI, we're going through a similar, if lower stakes situation in, for example, in this space where many times actually AI systems might be better than the status quo, even though they're not perfect and AI bias is still an issue. What does that mean about whether we should use these systems and trust them or not? If we can see that the data is showing that they are on average better. So anyway, interesting food for thought on that front. And I think that's the end of my slides. Back to you, Tina.
Great. Thanks so much, Jeff. I always love seeing the data that you've aggregated across a number of different providers in the space. And, as you suggested, the stakes are really high, which is why, the EU AI Act considers the use of AI in recruiting as high risk. I'm wondering what you're seeing, right, as the laws continue to change, whether it's, US laws like Colorado, Illinois, New York, certainly, or even the potential delays of the EU AI Act. What are you seeing in terms of regulatory developments? And while you maybe think about that question, I'll also invite the live audience with us today to drop any questions that you may have for Jeff or myself into the chat, and we'll take those along with the questions that we've preceded.
Yeah, so the question is what am I seeing in the regulatory development? So a lot's going on, that's for sure. I think you mentioned the EU Act and US states. I think one insight that surprises many people is how US states are regulating AI very heavily and rapidly. So I mentioned a few of the kind of laws that are most relevant and kind of alive or soon to be live. But we actually had a stat the other day that there's something like 17 new AI laws proposed at the state level every day in the start of 2026. So, US states are really looking at this issue, really worried about the potential, harms of AI. Meanwhile, in Europe, there's one big law that's actually just recently been mostly delayed till next year. And so, we've got this perhaps surprise situation where the EU and certainly the UK, there's no AI regulation whatsoever, has less regulation on the AI. Meanwhile, the US states are regulating it quite aggressively, which is, just an interesting insight. So we're seeing a lot of that. We're seeing a potential kind of patchwork challenge with US states having overlapping but ultimately distinct regulations in the absence of a federal one, which may be something that gets turned over, or maybe something we just live with, as we have lots of different tax laws and various laws per state in other domains. So yeah, anyway, but I could ramble on, but an interesting time for regulation development in this space.
No, I think so. I think that's right. And some of the delays, right, that we've seen means that vendors like ourselves need to be ready kind of at any moment's notice. And I think the things that we're trying to do are get ahead of it by working with auditors like yourself that help us prepare not only for the laws that are already in place, the hard laws, but also the ones that are coming, as well as the soft law around this particular area, which is evolving quite rapidly. I have another question for you, and I think you and I have talked about this even in recent times, is with the changes in what we're seeing around what the EEOC in the US is doing, right, in terms of approaching disparate impact enforcement. I think I'd be curious if you have a read on the current direction that they've set and what it means for companies using AI in hiring.
Good question. It's definitely interesting and could be a very significant change. It's been long-standing sort of status quo of looking at disparate impact, by the OC and so on, that if it holds, be upturned, and so quite significant change. And without kind of commenting on the political side of it and any views there, what's interesting to think about the potential impact on AI systems, and our space is AI bias, right? Not like just the overall human selection process, but the actual AI part of it, of what the impact could be there. And one of the focuses of that ruling is to focus on there being an intent, right? Not just that there happens to be perhaps an accidental disparate um, outcome between groups, but there needs to be intent behind it. And when you apply that to an AI system, what does intent really mean? Right? Does it? You can have an AI system that has systematic disparate treatment. Let's say based on names, like an simple example, it leans to favor one demographic group over others. But that could happen by accident. Like a person who developed that system may not have been or who deployed it, may not have known that, may not have wanted that. So there wasn't intent on the person building it. The AI doesn't really have a will, so it's not got intent in that sense. But it is still actually potentially disparately treating people, not just disparate outcome, but actual treatment, which you can, a system like ours can actually test and demonstrate that the AI uses those proxies to actually be biased. So I think that's a really interesting kind of area, and it could be a lot of focus on that approach to evaluating essentially how AI potentially is disparately treating instead of disparate impact. So we're looking at it closely, and it could mean down the line that we adjust or remove a part of the methodology that we do currently, which is that disparate impact analysis, of course, if that is the way it lands and stays. But it still shines a kind of light on how that counterfactual consistency technique I was explaining really looks at that disparate treatback, which we think is still very aligned to what will be left after the change.
Yeah, I'm so glad that
what do you think about it?
Yeah, I'm really glad that you highlighted both measures, not only the disparate impact, but also when you went over in your presentation the counterfactuals. I think you're asking, your companies that you're auditing if they'd like to pursue both, and certainly here at Findem, we also believe that the counterfactuals will have longevity and I think make a ton of sense for AI. And in some ways, the thing this makes me think of is maybe the historical bar was sort of innocent until proven guilty, and maybe AI is guilty until proven innocent. It's kind of how maybe we're thinking about the dynamic a little bit differently today.
Totally. And what's different about AI is we can be more proactive about it. We can test it before it goes live. We can do high volume statistical tests that you can't really do with humans in an easy way until it's been live for a long time. So they're definitely not like for like, and overall we need to see more. And we're playing a role here in how we test AI systems slightly differently from how we should test the human part of the process. Both are obviously important. Anyway.
Yep. There's another question that's come in here from the audience for you, I believe, Jeff. It's when a candidate gets rejected by a system you've audited as Warden assured, can they see that audit, or is it just a badge on the vendor's marketing page?
Good question. So the way it works, you audit typically vendors, in some cases employers as well. Well, let's say it's a vendor, a platform, and we give them various outputs of that, reports and a dashboard that we host and show those results. They're actually updated on a regular basis. That's a core part of our method. And typically they're shared with end customers, often on a website that can be accessed by other people, but it's up to the platform themselves how they want to do with that. So there's not like an explicit, for this particular candidate, here's the audit for you, or come and see more. But in many cases, that is public information. Not in every case, that someone could go and look at as well. But I don't think anyone's actually saying to each candidate, here's the Warden AI audit, to my knowledge.
Yeah, I think that's right. And I mean, I think the way that we handle it here at Findem, I think you provide the report, we make it accessible through our trust center publicly. And so I think, the transparency around a lot of what we're seeing in AI is so important, not just for complying with laws, but also making sure that candidates feel comfortable being evaluated by AI, and some of the legislation, especially here in California, that we're seeing come down the pike as maybe one of the states that's leading the nation in terms of how do we think about this. There's another question that's come in. I don't know if you want to take it or would like me to take a pass at it, but it is this: how do you audit bias in systems that combine traditional machine learning models with LLMs in the context of, for example, matching and ranking?
Yeah, so I can take this. So our approach is what's called black box testing, which means black box has got a bad connotation, but in this context, it's a good thing. It means we actually don't know or really actually want to know how the sausage is made, as it were, like what all these things are. Is it a machine learning model? Is it a large language model? Is it it could even be like a relatively simple rule-based system. We treat it as a black box. We test, here's inputs, what are the outputs? And from those inputs and outputs, we can examine the behavior. Which means in the case of matching, we would send, various resume, conversational chatbot, AI transcripts, whatever it is that it uses to do its matching, and get the outputs. And then we would do all those kind of fairness metrics that I mentioned based on that. So for us, the beauty of our approach is that it doesn't matter what type of model it's using. We work with companies that do all kinds. It wouldn't change the process and how it would work, and it would be consistent from the bias testing point of view.
Oh, that's helpful to know. And I think the one thing I might add is just I think it's important that regardless of what model's being used, it's sort of what is the deployment on the back end. So, I might just add for systems that provide the full list of candidates that were generated in matching and ranking, that matters in terms of the AI not cutting off a certain portion of that list. And so I think, again, looking at the nuances of kind of what the AI is doing versus what humans are doing in a system like the one I just described, the human is actually making the decision based on better information that AI is providing. So I think we'll move on to a couple of other questions, and we'll keep taking ones from the audience that come in. But I think, as we think about the study that came out of the Human-Centered AI Institute at Stanford, Balmasami and colleagues, it just literally got published um, just last month, I believe. And there's been a lot of talk in circles around, the fact that this was a very well-known vendor who had passed bias audits, where we had this sort of monoculture finding, which I think might be relevant for other cases we're seeing in the courts involving AI and recruiting decision making. Jeff, I don't know if you can offer any advice for companies wanting to make sure that it's not just a false positive on the audit, that truly, right, it's capturing what it's intended to capture and not masking due to aggregation of data. What would you recommend?
Good question. I think, yeah, so one of the findings and kind of critiques that the study has of that particular company's platforms audits was that it was only on the group like aggregate level, not on a per job level. So when you got more granular, there was potential bias found in the way that worked. So I think one of the things that's important is to dig into those audits and look at how granular do they get. Is it just the macro, disparate impact over the whole group? Is it break it down more? Does it do even what's called individual fairness testing, individual bias testing, which is that counterfactual thing that I've been talking about? So interrogating the and understanding the vendor audit and how deep it goes is valuable. And like I said, the takeaway is that only a kind of naive aggregate, really broad group analysis is not might not be sufficient to uncover the actual bias underneath it. And the other thing that some people might want to consider doing is a company deploying an AI tool can also have audits and kind of do some monitoring as well on their use of that system. So vendor audits tend to cover a range of scenarios or do things that that are across data from all their employers using it, and so it becomes hard to get a true kind of granular, realistic view of what it's going to be like on your particular jobs that you hire for, and even do it on that job level for your use. So it's something to consider is doing kind of additional bias auditing as an employer using an AI tool, which is an option as well.
Yeah, and perhaps that's related to the last question that we'll take before we close out the session here in the time that we have left. And it's just a follow-up question, which I think is relevant for kind of enterprise customers. But here's the question. Sort of a lot of vendors are using kind of multiple platforms, and it's impossible to figure out sort of which ones are at play in terms of the outcomes. So if you have Workday, Phenom, and others that are using third-party scoring tools like Schema AI on top of their core platform, sometimes 10 or more integrations deep, given that many of those integration partners are built in countries with no employment bias laws at all. How does Warden actually audit the vendor as a whole?
Yeah, it's a good question. So we see a mix of what happens in the market in this case when when a vendor uses another vendor to help power the system. In some cases, we will. An example, given there, they actually are a customer of ours, the company providing the scoring tool. We will have audited the actual companies that are providing those as well. Um, but we also case, and so that will often be what the like top level vendor, if you will, like takes on and passes on. But also, again, to do that black box approach I mentioned, where like we don't need to know what's under the hood, we can do it. We can come in and just do it on top of all of those things, which we also do for some companies where some cases know they're using a different tool powering it. In some cases we don't even know. And it doesn't actually matter. We're still able to test and just whatever happens just flows through in that black box. Maybe a very complex black box, but still the overall outputs can be tested against those inputs and analyzed in the same way.
Yeah, and I love where this is headed, right? Because I think it's a window into the future of what enterprise organizations are going to need to do for themselves as they use AI to automate so many parts of the process and transform it going forward. So appreciate kind of the approach that you're taking and sincerely thank you for the time that you've taken not only to share some of the research around underpinning your work, but also to answer some of these questions that I think are top of mind. And with that, I'm just going to close us out with a recap on maybe where we spent our time today and what we learned. And then we'll share a little bit of information on where you can find Jeff and I if you have questions going forward. So just bringing us back to where we started at the top of the hour, I asked you to hold a hiring decision in mind, one where you suspect bias crept in, yours or someone else's. I think we saw in the chat that both anchoring bias and representative bias came out as top winners of human bias. But now we've built this 4-part framework about what to do about bias, human bias, and also bias that enters AI. So first is name the bias, anchoring, representativeness, halo, effect, give it a name. You can't interrupt what you actually don't identify. And that's step 1 that we took in the chat conversation with those identifying what biases they're encountering. Second is design against it. Attribute-based AI, structured criteria evaluated in parallel without any sequential anchoring. The design of the tool is the intervention. It's not a diversity program that's layered on top of bias process. Critically important. Third, audit the design, and this is where Jeff's work comes in. Don't accept a pooled audit at the face value. Ask for the position level analysis. The Stanford research is just, it's not a cautionary tale about bad actors. It's a cautionary tale about aggregation methodology. And a clean aggregate audit can coexist with discriminatory position level outcomes, which we want to guard against. And then finally, watch for this monoculture issue. One dominant vendor across your industry means sector scale correlated risk. And you're not just managing your own compliance exposure, you're part of a system. And that's the system we've just been talking about. Knowing what the vendor's models was trained on and where its biases propagate is really important. So before we leave, I'll ask you to type one more thing into the chat if you're willing. One thing that you might watch out for in your organization's AI talent process this month, now that you've heard a little bit from Jeff about the way in which to audit, and make that, maybe perhaps your commitment to action, because I think in all of these sessions, we like not just to talk about it, but to actually take action and make things happen. And in this case, making sure that there's fairness in AI employment decisions. So as you think about what those things could look like, we'll go ahead and close out. And on behalf of Jeff at Warden and all of us from Findem, thank you for the quality of the conversation today. It's exactly what I think practitioner engagement that makes governance real rather than theoretical. And the recording is going to be available, though the slides will not. And our August session will pick up on governance arc with the AI usage and transparency. We'll announce the faculty in pre-reading in advance. Please do stay in touch. Jeff and I are both reachable if questions surface after you've had a time to sit with the material. You can reach us at the email addresses here. We'll also be following up with an email note to participants with the thought leadership underlying some of the research that we presented. So again, thank you, Jeff. And we'll see the rest of you in August.